Okay, in this lesson, we are going to explore more deeply some of the things that we can do with sagas so that we can get a better understanding as well of how the saga library works. Now, unfortunately, we have to step outside of our existing library in order to take a better understanding of just the base functionality of some of these other effects that we've explored inside of Redux Saga. And to demonstrate, we have a very simple application that is pretty much just a typical numbers logger. We have this button that increases the number, and then this other button that decreases the number. And all it is it's a simple reducer, right, that holds a value number. And then depending on the action, if it's an increment or a decrement, it increases or decreases the value. And then our component just pulls in both the action creator, right, that will dispatch an increment or dispatch a decrement action, and pull in the value of the prop as well, and set it to the value, which we then just display inside of a simple component. Very simple application setup. The main thing that we want to demonstrate here is our ability to understand what sagas can do. So inside of our code, we have this app saga file that we can write our sagas for the first time. And what we want to do is we want to look at the difference between some of the, at the very least, the base listener effects that I talked about. So we want, for example, we're going to look at the base one. So we've seen take every, but there's actually a base take one as well. And there's a difference of what it does. So I'm going to explain to you what this one does, right? Just the base take, and how it differs from take every and take latest, which is another one that we're going to look at. So here we just want to look at take. Now, we just want to write a very basic saga. So I'm going to export a saga function called basic, or I'm going to type increment saga. Now, what we're going to do is we're going to yield to our take function, and our take is just expecting the increment keyword. Unlike take every, we don't pass to it anything in the second argument. Instead, what take does is it waits for this action of increment to happen. When it does, we're able to actually get the payload from this action as well if we wanted to. If we wanted to, what take does is it gives us back as a promise that gets resolved the actual payload value of this action, if we had one. If we wanted to set it, we could just say increment payload, and we would set it like that. That's the main benefit of take. The other thing about take is that the rest of the code does not execute until this take operates. So it's pretty much the same as take every. The only difference is that we would write out our function respectively. So if we wrote a console log here, I am incremented, well, we would not expect this code to ever log until our increment action is caught by our increment saga. Now, in order for us to test this, we have to bring this into our store. So we'll just import in our increment saga from our app saga and run it inside of our app middleware run. And now if we open up our logger, we'll see that when we hit add one, we are firing our I am incremented because now we've actually triggered the action. But one of the big differences between take and take every, as we used in our clothing application, we'll notice that whenever we click and fire off the increment action again, we're not actually triggering our I am incremented console logs anymore. Well, this is actually because take is following just the basic generator function that we learned about a few lessons ago. Do you remember when we learned our generator lesson? That we were able to call next until we ran out of yields, and then on the last next that we called, we would get either no value if we don't return anything from our generator function, right? But the completed property would say true, and then we would never be able to restart our saga, right? Which is the nature of sagas. You cannot go back into the saga and then start from top to bottom again. Well, this is interesting because when we notice with take every kicks off a new task, right? Using the generator that we pass to it as its second argument for every increment action that comes in. So let's explore that a little further. Let's make a new function, right? Another generator function called onIncrement. Let's just say that. And inside we yield a console log I am incremented. So instead of using take, we use take every, and then we fire onIncrement. Now, what's happening here is that whenever we trigger this action, under the hood, Redux Saga is firing off a new task to run our onIncrement Saga code. So every time I am incremented is being fired, Redux Saga is actually regenerating that generator, right? It's calling this onIncrement generator again and again and again and again. So it's not running through the same increment saga. Instead, what it's doing is it's looping and listening for every increment call and then creating new iterations or new tasks that are equivalent to whatever generator function that we pass to it. And that's the big benefit of using take every, because now we're able to actually loop and reuse this increment code more than one time and listen to all actions that come from increment. We can actually write this ourselves manually with take using a while loop. So if you're familiar with a while loop, what a while loop does is it essentially executes the code inside of this block based on this conditional. When the block is finished executing, it goes back up and it checks the conditional again. If the conditional is still true, it reruns the block again. So if we force true, we'll actually be able to run a yield on our take where we can say increment like this. And then let's just import take as well. Let's copy that over. And now we'll see that no matter how many times we fire off this action, this code will work because our generator function never completes. It will always go back into the while loop and get stuck because our conditional is true. So it'll always say yield take increment. It's true. Okay, I'm going to console log I am incremented. In fact, we don't even need to yield it, but that's what will happen. It'll say I am incremented. And then it'll redo the loop because our conditional is true. And it will always be ready to take new increments. Every time an increment action comes in, it console logs I am incremented. It then restarts at the top of our while loop. This is pretty much a way of seeing what take every does for us. The only difference with take every is that take every also spawns these new sagas, right? These new task-based sagas concurrently, which means that it's non-blocking. Which means that technically speaking, if I were to imagine a set timeout here. In fact, we can get an effect called delay from Redux Saga, which is the Redux Saga way of doing set timeouts. If I were to yield delay and I pass it 5,000 milliseconds like this, you'll see that when I click it the first time, I get I am incremented. If I click it the second time, the third time, and the fourth time, you see it's not working, right? Because this code right now is being blocked by this delay. This delay 5,000, you can imagine like an asynchronous code. If we had some API request here instead, what's happening is that whole function is frozen, waiting for this delay to finish. If it was an API request, it's waiting for that API request to come back. Now that 5,000 milliseconds has passed though, if we fire again, we'll see that our code continues to work, right? That's the main difference, is that this code is blocking any future take increments coming in from being called. Whereas take every is creating new subtasks. It's spawning new sagas for every increment action to come in, which means that 3 increment actions are running on 3 new onIncrement sagas. Meaning that if our code goes back to using our take every instead, So we'll say increment, and we'll pass in our on increment. If inside of here we had a delay of 5,000, this does not stop every other action, as you can see, from getting the IAM incremented code from running. Because again, take every is spawning new sagas on every increment action coming in. Now, I'm not going to say which way is the right way to do it because they're both just patterns. You might want, for example, code to be blocking, right? You might want to write it with that while loop using a regular take if we want to debounce requests, right? Debounce meaning that, let's say we don't want them in 5,000 milliseconds to be able to spawn and fire multiple sagas, right? We don't want them to run multiple console logs. Or if we had more complex logic here, we don't want them to run that multiple times back to back. Maybe we want to debounce those clicks. Maybe we want to wait for the first one to finish. Or maybe what we want to do is wait for the last one. We want to cancel any of the previous sagas that were fired. So here's an interesting thing that we can do. Let's say, for example, we wait on this increment action to come in. But instead what we do is we have a separate action that actually increments the reducer. So what do I mean by this? Well, right now we're listening for increment to increment. What if we say increment from Saga is the action that actually triggers this? What we would then be able to do is take our put effect, and after a delay of 3,000 milliseconds, we would then actually fire off our increment from Saga. And this would be the actual way for us to actually increment from Saga, right? There's always a 3,000 second delay. You can imagine that this is some kind of asynchronous request. Now what happens if I click this 3 times? After 3 seconds, we'll see that our increment from Saga resolves, as we would expect after the delay. We end up firing our new increment from Saga action that updates our reducer. But what if what we wanted to do was that we only wanted the last one, the last click within these 3,000 milliseconds, right, before any of them resolve, to be the actual one that does get resolved? Well, we can use take effect that we're going to look at in this lesson called take latest. Now what happens is that no matter how many times I click this, it will cancel all the previous ones and only trigger the latest one that was clicked. In fact, you'll see that IAM incremented is still getting logged because this first yield is synchronous. So each on increment that gets fired in our take latest is still immediately resolving. It's still spawning a new saga every time we clicked. But because our delay is 3,000 seconds, meaning that our function, right, our generator function here is stuck here for 3,000 milliseconds. Remember when I said with yield, we're yielding control back to our Saga middleware library so that it can cancel any of the ongoing sagas if it wanted to? This is exactly what's happening when we do take latest. Even though these new spawn sagas, whenever we clicked increment, are being generated, hence why we saw the IAM incremented on every click, we only ended up resolving one increment from Saga because whenever it hit the delay and those latest clicks were coming in, Redux Saga was actually canceling every previous spawn saga that was generated except for the latest one. That is the big deal with Redux Saga. This is pretty much the core of the architecture of how sagas are formulated. And this hopefully explains to you how we can leverage Redux Saga to give us many different effects, such as debouncing, but also it allows us to understand how with sagas we can cancel them so that they don't take up more time, but also how it allows us to run multiple tasks concurrently in our background. Now, I'm hoping that this all made sense. This is pretty much the basics of how sagas work. Now, with this information, we're going to move on into the next lesson where we're going to make importing sagas into our store a little easier. But if you're confused, please rewatch this video. The more you watch it, the more you see the differences between take, understanding generator functions, understanding this idea of creating new sagas, right? The better you'll be able to understand what's actually happening with sagas.